We're going to open this lectures on this opening problem. Let's say you have the need to store 100 numbers by manipulating them, by computing their average, or by finding out the maximum number amongst them, or the minimum amongst them. No matter what you do, you have to manipulate these numbers. Most importantly, storing them in the computer memory. Imagine that this is the boundary where you'd be storing these 100 numbers. That boundary is what we call a data structure in computer science. In this lecture, we're going to talk about one data structure and the most ubiquitous of all, array. The concept of array is not new. This is ubiquitous in the sense that you'll find this same data structure and naming convention in other programming languages. Let's introduce arrays. What you see here is a collection of data. This collection of data all have the same type. Let's say they're all of type double, and we want to store them together. This is what your array looks like. There's a name or a reference to this newly created array. By the way, this use of new is being done on a heap, which is a part of the memory where this collection of 10 doubles are stored. So inside this heap memory, we see that there is a list of 10 doubles, and they all occupy a unique position next to each other. This is what array visually looks like. Array also has indexing. We'll talk a little more about this. Starting with 0, you will use the bracket notation to indicate each element position. The very first elements in the array will be at index 0. This is index. The second element will occupy index 1. The third one will be at index 2. This means that your index value I can go from 0 index all the way through the array length -1. MyList is a reference to this location, or the beginning address of the array. And remember, reference means memory location. In certain context, memory location is a memory address, which is a hexadecimal number. This MyList actually holds a number, which is a hexadecimal memory address of this entire list starting at 0. So this is a quick overview of how we create or dynamically allocate some memory to allocate space for 10 unique double type integral values in your heap memory using Java. In the opening problem, you would create an array of 100 numbers because that is the input size of the problem, 100 numbers. You can store every single one of these numbers as you would here to begin your computations. Let's look at how we declare and create these arrays more closely next. Before you can create your array and making use of it, you have to declare it. Declaration of array is with a type followed by square brackets. The type in this case is double. If you want all of your content sitting inside the array to be of integer, then you would say integer. If you want them to be string, you can simply write string. Just remember, all of the elements sitting inside of a declared array have to be of the same data type, and you give it a name with a semicolon. The other thing to note is that bracket notation typically follows your data type without any spaces in between. In some languages, you might see the use of bracket following the array reference instead, but this one is not preferred. In fact, I believe in C++ you will write something like this. Either one is fine. I prefer writing it this way because this gives you an indication that one, because of this bracket notation, that this is an array. And because this is all of double, then what you have inside of it is an array of doubles versus doing it here, which is kind of hard to read. Now that we declare an array reference, let's see how we can create the array and assign the memory address to this MyList reference. Creating array is the same as instantiating them. Instantiation is the same as creation. In programming context, you will use the new operator, specifying the type of element you will hold and its size. This data type must be the same one that you used to create your reference. In other words, you can also inline this by saying MyList, which is the one that you have from the previous page, like this, or this. You can say equals new double 10. This gives you an array of 10 doubles. In a Java world, this array of 10 doubles all have some default values of 0.0. If this had been an integer instead, then every single one of these elements sitting inside of it would have a default value of 0. So there are some default behaviors associated with Java. This is not true in C, C++, where uninitialized variables are what's called undefined. They could bear any values in general. As we stated earlier, using the bracket notation and the indexing position gives you the nth location of the elements in the array, where n could be anywhere from 0 through length minus 1. In an array of 10, your length is 10, and the very last index is 9, because the array starts with indexing 0. This is how you instantiate or create an array dynamically in a heap using new. Let's look at declaring and creating an array in a line of code. It turns out you can declare an array, create a new array, and assign the latter to the former in one line, as illustrated here. On the right side, you have what's called the R value, which is dynamically created this data type array with a certain amount of size, and that returns a memory address. Remember, we talked about this. That memory address of however many elements you should have arrays pointing to its very first address, or the beginning address of the very first element of the array, index 0. That address is being returned and stored inside this reference variable of the same array type. This is where your array journey begins. This example is the same as that one, except the location of your bracket notation for the array shifted here for best practices. This option also compiles.